Hello, my name is Ethan Melton, and today I am showing you the importance of sequences within mathematics. Let's start with a warm-up. Look at these patterns of numbers. What is happening in these patterns? What do you notice? These patterns are examples of something we call a sequence. So, what exactly is a sequence? A sequence is an ordered list of values that follow a specific rule. Each value in the sequence also has a specific position. Here's an example. This sequence 2, 4, 6, 8 follows the rule of adding 2 for each value. The value 6 is the third value in the sequence, so it is denoted a sub 3. There are two main types of sequences, arithmetic and geometric. Arithmetic sequences are those that add a number each time, like the sequence we used before. Geometric sequences instead multiply by a constant value each time. Looking at these sequences, which seems to be growing faster? Why is that? Sequences can also be represented in two main ways. These ways are recursively and explicitly. Recursive representations are dependent on what the previous value is, like in this equation. The recursive equation gives you the initial value, in this case 0, and then gives you a rule in which you must follow to find the next value. Explicit representations give you a specific formula in which any value can be found. While explicit formulas are easier to find values, it is much harder to find the explicit formula than the recursive formula. To you, which method seems easier to use? Are there different situations where one is better than the other? Explain your reasoning with a classmate. So let's see how both arithmetic and geometric sequences are modeled visually using Desmos. For the arithmetic sequence, let's use the equation a sub n equals 3n. As we can see, the values in the sequence increase linearly. For the geometric sequence, let's use the equation a sub n equals 3 to the power of n. We can see that these values increase exponentially. In the arithmetic sequence, we are adding by 3 each time, while in the geometric sequence, we are multiplying by 3 each time. We can see that the geometric sequence grows much faster than the arithmetic one. By using Desmos, we can easily see the behavior of both these sequences, as well as easily compare them. Now let's look at some real-world applications. Let's start with the arithmetic sequence. Let's say you want to save your money to buy a car. You plan on saving $200 each month to buy a car that costs $5,000. How is this situation modeled? Is it by adding or multiplying? How do you know? In this example, we will be adding each month. But what value are we adding? We will be adding $200 each month. So this problem can be modeled using the equation a sub n equals 200 times n. Using this equation, how many months will it take to buy the car? We can find this by isolating n. We first know that a sub n, or our final value, is equal to 5,000. We can then set 5,000 equal to 200 times n. We then divide on both sides to get 5,000 divided by 200 equals n. It follows that 5,000 divided by 200 equals 25, or our value n. This means it would take 25 months to save for the car. Now, let's look at geometric. Let's say you have $5,000 in your bank. The bank gives you 0.39% interest each month for having your money in their bank. How will this situation be modeled? Are we adding or are we multiplying? In this case, we will be multiplying. But what number are we multiplying by? To find the number that is being multiplied by, we take our percentage, 0.39, convert it to a decimal, 0.0039, and then add 1 because this is exponential growth. This gives us 1.0039. This problem is then modeled by the following equation. A sub n equals 5,000 times 1.0039 to the power of n minus 1. Why is it n minus 1 instead of just n? Discuss with a classmate. How many months would it take to reach $6,000? Like the previous example, we isolate n. We know that the final value, a sub n, is equal to 6,000. We can then use our equation to isolate n. We can divide 6,000 by 5,000 to get 1.2. Then, in order to bring down the n minus 1, we must find the natural log of 1.2 over 1.0039. We can then add 1 to both sides to find that n is roughly equal to 47.84. This means that it would take roughly 48 months or 4 years for the amount to equal $6,000. So, what have we learned? A sequence is an ordered list of values that follow a specific rule. We both have arithmetic sequences and geometric sequences. We can represent sequences both recursively and explicitly. Desmos is a powerful tool to visually show the behaviors of sequences. Sequences are used in the real world to evaluate problems such as saving money and bank interest. Here are some homework problems for you to try on your own. I hope you enjoyed this presentation and better understand the importance of sequences, both in mathematics and in real-life applications. Thank you for watching and have a wonderful day.